afternoon. We are at Ribbon's booth here at OFC with Sam Bucci, Chief Operating Officer for Ribbon. We're here to discuss the future of optical networking and Ribbon's initiatives to support our customers. There's no better place than here in our booth, and where all the latest innovations are on full display in optical networking.
Thank you, Joni. I'm glad to be back at OFC, which I'm pleased to see has returned to operating at full throttle.
Absolutely. Well, let's jump right into it. I'd like to set the stage and help us understand the primary goal for optical networking today.
Well, Joni, there are several goals. The core mission is to transport high-capacity signals, such as 100 gig, 400 gig, and soon 800 gig services at really the total lowest cost of ownership per bit. These are the service speeds within data centers, and the goal is to break down data center walls by transporting them transparently over the wide area network. On top of that, we add automation and intelligence to make it easier to deploy and operate optical networkings. And finally, we need flexible solutions that provide network operators with investment protections such that they are able to benefit from optical innovations, but in their brownfield environments.
And help us understand about the application areas. Do we still focus on distinct markets such as metro and long-haul optical networks?
Well, Joni, while metro and long-haul serve different geographic needs, that's not primarily what is driving the market today. Instead, there's really two streams of transmission technology innovation. One is capacity reach optimized transport, and the other is power cost optimized transport. Both of these have a role in the metro and long-haul sectors. And then, of course, for optimization and control, we have the driver of adding intelligence and automation.
Let's dig a little deeper into that. Help us understand the capacity reach optimized transport.
Well, Joni, capacity reach optimized transport relies on the use of high power consumption transceivers with advanced digital processing to maximize the line rate and channel capacity for any given distance. Today's state-of-the-art uses 5 nanometer silicon technology that operates at up to 140 gigabaud and can deliver fast wavelength speeds of up to 1.2 terabits per second.
And how does this compare to previous technology, and what use cases does this open up?
Well, Joni, until now, the best wavelength speed was 800 gig, but really for limited distance. Today's 140 gigabaud transmission opens up multiple new use cases. For example, we can provide data center interconnect solutions across metro areas at 1.2 terabit, which represents a 50% increase in capacity with lower power use. The second is we can extend 800 gig to over 1,000 kilometers to cover entire geographical regions. And last but certainly not least, we can run 400 gig across the world, including changing the economics of subsea transmission. By the way, just to circle back to the primary mission of optical networking, all of these wavelength speeds are important for efficiently transporting 100 gig and 400 gig services.
Absolutely, it's all very exciting. How does power cost optimized transport fit into this?
So power cost optimized transport uses lower power consumption transceivers that conform to industry standards and are available from multiple vendors, making them lower cost. They still provide strong enough performance for large segments of the market and the application space. Today's power cost optimized transport can deliver 400 gig for metro applications, and in less than 1 year, we will see this double to 800 gig for metro or 400 gig for long haul and ultra long haul. So between both of these transmission optimizations, we can tailor optical transport solutions for our customers for all geographies and traffic densities.
So can you also amplify the role of intelligence and automation for these transport optimizations?
This part is incredibly important to lower ongoing operational expenses. Intelligence and automation extracts the most value from the transport technologies we've covered so far. So this extends from transmission and power optimization to performance monitoring and high-level analysis to higher-level network-wide functions like zero-touch provisioning, for example, and dynamic restoration. So by combining state-of-the-art transmission technology with intelligence and automation, we're able to minimize total cost of ownership per bit.
What's Ribbon's strategy to succeed in this fast-paced environment?
Well, Joni, our strategy really is to be a first adopter of industry-best transceivers for these two transport optimizations. We use these to craft solutions in both standard telco and new high-density compact modular platforms. Then we combine this with the intelligence and automation that's required to stitch it all together and provide our customers with a competitive advantage of lowest cost per bit solutions, whatever their application.
So we're here at the booth here with in OFC. Do we have this new high-density platform for demo?
We certainly do. It's the Apollo 9408 compact modular platform. It's 600 millimeters deep with front-to-back cooling, enabling it to support the highest level of density in the industry at 19.2 terabits of capacity in a 2RU height. We are showing it here with two types of sleds, supporting both the capacity reach and, of course, power cost optimized types of transport. Our capacity reach optimized transport sled uses the industry best 5 nanometer silicon technology transceivers that operate up to 140 gigabaud. It supports speeds of 1.2 terabits per wavelength for short haul and 800 gig for over 1,000 kilometers. This is the most advanced high performance solution on the market today. We enable a full range of solutions, really right from the cell tower and mobility, metropolitan and regional networks, across continents and underneath oceans. Moreover, we're participating in a unique live demo of this technology at the Open ROADM booth, where we are showing interoperability with a similar solution from Cisco at 1.2 terabits. This demo launches a new era, proving we can create for the first time an interoperable multi-vendor ecosystem for high-performance optical transmission. Our power cost optimized transport sled uses ultra-small form factor QSFP-DD pluggables. This supports 400 gig today with, of course, the industry best density of 19.2 terabits in a 2RU platform. The sled also has a unique ability to be upgradable to 800 gigs simply by swapping out the current pluggables to a newer generation when they are available later on this year.
So there has been a lot of buzz around the Open ROADM POC that we're participating in, and that's been pretty exciting. Help us understand a little bit more how network operators can start deploying our 9408 platform. Do they need to buy the complete Ribbon optical system?
Oh, well, no, Jody. At Ribbon, our design philosophy is that all of our networking systems are open, making them easy to deploy in existing networks and also deployable in piece parts. So our Apollo optical transport runs over all major optical line systems, and they are controllable directly using our industry standard APIs. In addition, operators can also purchase our optical line system separately. This includes the high-density sister of the 9408, which will support up to 32 ROADM degrees and is designed specifically also to support IP over WDM or coherent routing.
Sam, we have other parts of our portfolio here at OFC. Can you share a little bit more insights of the entire product family?
Well, certainly. So staying on the optical transport subject for one more minute, we're running a live demo at OFCnet, which proves our claim of investment protection and reuse of brownfield networks. Essentially, we're providing a 400 gigabit Ethernet connection between the OFC show floor and the San Diego Supercomputer Center, but doing so over a highly constrained fixed 50 gigahertz channel. We're also showing how we build intelligent middle mile solutions for our customers by integrating three product families. The first is our world-class Apollo networking that we've been discussing until now. The second is our Neptune IP routing portfolio, which features best-in-class routers running under Ribbon's mature network operating system, and also supports coherent routing using small form factor pluggables. And last but certainly not least, the intelligence part of all this is our Muse SDN domain orchestrator, which adds network-level intelligence to Apollo and NPT. It delivers multi-layer IP optical control and automation, which helps our customers streamline their operations for lowest total cost of ownership. We're also showing a live demo of Muse operating a remote network, and the feedback, Joni, I must tell you, has been incredibly positive. Anyone who's seen it for the first time say without hesitation that it is the best SDN controller of its type in the market. At Ribbon, we consider ourselves the middle mile experts. We create intelligent middle mile solutions that are service aware, highly flexible, multi-layer, and have the lowest total cost of ownership.
On Monday night, Ribbon received a LightWave 2024 Innovation Award for our Apollo MPQ-8 high-density card. Tell us why you think we won this award.
Well, Joni, the card, the NPQ, has been getting great feedback from our customers, and it is the densest 400 gig MUX on the market. We are providing a new lower cost point for essentially networking 400 gig, which is why I think we received the prestigious award.
Absolutely. Well, Sam, thank you for your thoughts and insights. Appreciate it. Are there any final words in summary you'd like to share?
Well, certainly, Joni. So our commitment at Ribbon is to provide our customers with service-aware middle-mile networks with the lowest TCO. And we do this, as I mentioned earlier, by bringing together open and optimized Apollo optical networking, our Neptune IP routing solutions, and last but not least, our Muse SDN control solutions.
Thank you.